We have talked about a lot of the properties of graphs. We've talked about finding zeros. We've been working on how to break down a polynomial if we have zeros. We've talked about in behavior. We've talked about if a graph will bounce or cross at a zero. So now we're going to start connecting all these dots to draw graphs. When we graph them, I am going to ask you to do a series of steps. You are not going to have to memorize, I need to do this, this, and this on a test. I will break it down and I will ask you all these questions individually. So I will say, part A, tell me the end behavior of this graph. Part B, tell me the zeros of the graph, and so forth. So you don't have to memorize what you're doing in which order. I will have you find all that stuff for me. So the first step in graphing is to find that end behavior. And we've done that. We did it on our quiz the other day. We did it last week a lot. We know that's based off the degree, and we know if you have a negative coefficient that will flip that end behavior. Second thing we will do is find the zeros, which you were doing yesterday on your homework. If it's in factored form, it's setting each of those parentheses equal to 0. Third thing, we will decide if the graph goes through or bounces at each of those zeros. This was back in section 4.1, but we talked about if the zero has an even multiplicity, that's when the graph will bounce. If your multiplicity is odd, it will just go through. Then we'll find the y-intercept. How do you find a y-intercept? We haven't done that in a bit. Well, if it's a line, we put it in that form and we can tell. In general, what can you plug in if you're trying to find a y-intercept? 0 for x. So you'll plug in a 0 for all of your x's, and that number will be your y-intercept. And then we will draw a graph from that. Obviously, you guys still have your graphing calculator, so you will be able to check it. But I'm going to ask all these things, and each one of these pieces are worth points. So you have to be able to correctly identify each of these. And then in return, if I had you find the zeros, I expect those to be plotted on your graph. I'm not going to have you find all this information and then just, draw me a general shape. I want you to plot this stuff on our graph when we do it. So let's do a problem. We are going to sketch this by hand, and then we'll just use our calculator to confirm that we are correct. So here's our polynomial. Step 1, I want the end behavior. So if I look at this, a lot of times I may ask you to find the degree first, just because that would help us with the end behavior. What is our degree? We have 1x, so we have x times x times x, so it's overall x to the third. So my degree is 3. So you have to think about that to find the end behavior, so I might just ask that as one of the questions, what is your degree? So we know if it's degree 3, odd, looks like a chair. Do I have a negative in front to flip it? No. No, so my end behavior is down. Okay, next I'm going to ask you to find your zeros. Now if it's in factored form, that's really easy to do. You just set each of these parentheses equal to 0. So what makes 2x minus 1 equal 0? What makes x plus 1 equal 0? And what makes x plus 3 equal 0? All right. Then we are going to decide if the graph will bounce or go through at each of these. You need to tell me each one individually. So that is based off the multiplicity. All of these have a multiplicity of what? Just 1. Remember, the multiplicity is like the exponent, so if I put a cube here, then it would be 1/2 multiplicity of 3. Since there is no exponent, these are all 1. 1 is an odd number, so what does that tell me about the graph?
It goes
Through. So I'm just going to say through all of them. Alright, y-intercept. How do we get that? Alright, if I put in a 0 for all my x's, I get 0 minus 1, which is negative 1. 0 plus 1 is 1. 0 plus 3 is 3. If I multiply that, we get negative 3. Now, we're going to graph it. So my end behavior is down up. That means it should start down here and end up here. Zeros are where you hit the x-axis, so I need to plot those. So I hit my x-axis at positive 1/2, negative 1, and negative 3. Y-intercept is negative 3, so we hit the y-axis at negative 3. This is actually all we need to draw the graph. We know it's going to start down here, so it has to start here. Hits my first 0, and we said it goes through all of them, so it would go right through. It's got to come back to hit the next one. We have to hit our y-intercept. Let's come back and hit our next 0, and we said it keeps going through. Does my end point the direction we said it would? Yes. Now, is my graph perfect? No. For all I know, maybe this thing shoots way up here and then comes back and shoots way down and comes back. I don't really know. What I am looking for on your graphs is the correct shape. Do you have your intercepts marked? Do you have, a nice smooth curve? These things are not lines, they are curves. It needs to follow this general pattern. Yeah. Double check it on your calculator. Make sure you just plug in the original, and Reese already checked that for us and said we did a good job. Alright. Questions there? Ready for homework already? That was fast. Let's do a couple more together. Let's do easy one or hard one?
easy.
Hard.
Do this one. Oh, I don't want to do that one yet. Let's do this one. Alright. Can you guys tell me what the degree would be? We have 2 here and 3 here. So make degree 5. What's the end behavior then? I don't have a negative in front, so it doesn't flip. And behavior is down up. Alright, zeros. What makes x minus 1 equal 0? And what multiplicity does that have? 2. If you have a multiplicity, I want you to write it. So if it's not distant to the first power, you need to include your multiplicity. The next 0 would be negative 2, multiplicity. Alright, go through or bounce. At 1, what will happen? Bounce. Why?
It's even.
You check the multiplicity, not the 0 itself. You're looking at the multiplicity. If it's an even multiplicity, it bounces. What happens at negative 2?
It goes
through. It has a multiplicity of 3. 3 is odd, so that one will go through. Y-intercept, how do we get that?
Plugging zeros.
Okay, so 0 minus 1 is negative 1 squared. 0 plus 2 is 2 to the third. So we get 1 times 8, which is 8. Now we can graph. So my end behavior is again down, up. You don't have to write these little arrows, but I do that just so I can double check myself at the end and make sure it matches. My zeros, that's where we hit the x-axis, so that's at positive 1 and negative 2. Y-intercept is at 8. So we start it down here to come up and hit that. At negative 2, what do we do? Do we? It goes through. We would have figured this out. If we accidentally bounced, then I come down here, can I get to my y-intercept without hitting the x-axis? No. So I know right there that I have made a mistake. The negative 2 went through. You have to come back, hit your y-intercept. Come back and hit the x-axis at 1, and what happens at 1?
Bounce.
Bounce. Make sure when you draw that bounce, it is still curved. It's not like a zigzag. So kind of adjust your graph as needed, but make sure it curves. And then how can you check yourself and see how we did? Yeah, graph that original one. Let's see how close we were.
Yep.
Yeah, not too bad.
Mine doesn't.
Yeah, we've got, it had a little more of a zig right there, but we still hit the axes at the important spots. We've got the same general shape, so it's not too bad. Questions there? Let's do another one. Alright. What's my degree this time? Cool. We have to add them together when it's in factored form. But if our terms are added and subtracted, the degree is just the highest power. Alright, everybody with me here? So my highest power here is 4. Okay, so in behavior should be what?
Up, down. Alright, now.
Up, up.
Even.
Up, up.
Down, down.
So
But there's a negative.
even degree means the answer goes the same way, so up, up. But there's a negative, so it flips it, so it's down, down. Alright, the zeros. Can we easily tell the zeros here?
-2, 1, or -2, 1, 0.
Yeah,
Wait, can you just-
there's a difference in the two. When it's in factored form, the zeros are really easy to tell. We have to think about the degrees some more.
Back to
When it's written like this, the degree is really easy, but we're going to have to work a little harder for the zeros. We have to factor it first. Looking at this, what could you take out of everything? I'll just take out negative x squared. So if I pull that out, that gives us a 2x squared plus x minus 1. What could you do here? 2, add, we get a positive 1. What would that be?
2, negative 1.
2, negative 1.
We get 2x minus 1, x plus 1. So, my zeros. This out here. If you just have a plain x, what makes that 0? Well, no, makes x squared equal 0, so that's just 0. But it was a square, so its multiplicity 2. What makes 2x minus 1 equal 0?
1.
And what about x plus 1?
Negative 1.
Okay, so at 0, does it bounce or go through?
Bounce.
Multiplicity 2, 2 is even, so bounce. At 1/2.
Through.
Yep, multiplicity is 1, 1 is odd, so it goes through. And at negative 1.
Through.
No, 1.
So plugging in 0 for your x's, you have the option, you can do that in the original or our factored form. It's not going to matter, you should get the same answer. So if I just plugged it in the original, what do we get? Zero. Now we can graph. End behavior is down, down, both ends point down. We hit the axis at 0, positive 1/2, and negative 1. Hit the y-axis at 0, so we already have a point there, we're good.
It's down.
So, since it's down, down, it starts from the bottom. At negative 1, do we bounce or go through?
Bounce.
Negative.
No, go through.
Come back to 0, and at 0 it says bounce. Come back, hit the 1/2, and we go through. So it ends up pointing back. How close are we?
Can't really see like the bounce.
Yeah, this one isn't as obvious as some of them when we go to check it.
This looks like a graph, really.
Yeah, if we kind of adjusted the window on our calculator, we would get a clearer picture. But it is hard to tell on just the standard viewing window, negative 10 to 10, because it's kind of skinny. But if you hit zoom, and number 2, zoom in, and then hit enter, can you see it a little bit better there? So sometimes we may have to adjust the window a bit if you're trying to check. Alright, you guys think you can handle some of these?
Yes. Do we have an answer?
There is a handout posted on Classroom, and I set it on that post